Okie dokie. Chris is pushing the buttons. He's making the slideshows happen. And here we go. So, welcome everybody to, what's the date today? The 3rd of July, 2026. And it's a community practice. If you've never been to one of these before, this is an informative session for people who are either architects or interested in architecture, or I guess technology in general. This one in particular is a bit of a story about, I suppose, what happens on the frontier when we don't necessarily have to worry too much about all the governance and the guardrails and the process, and just there's this sort of an experiment into what a future can look like, where we sort of have an idea and just sort of go for it, and then we can kind of work out how we might make that safe and make that robust and things. Well, hopefully there's some learnings there for MSD in general. This is primarily sort of my side interests in this space, working sort of at that frontier. So here we go to the next slide. So look, we've been talking about agents for a couple of years now. So I believe it was one of the first talks I gave to this forum back in February 2024, where, this was at the old days when we had Gemini 1.0 and GPT-4, and Claude was just kind of coming on the scene, and people were talking about agents, and what's that? Is this some kind of matrix thing? Are they going to come into our workplace and take our jobs, and they're gonna be doing all sorts of weird things, simulating humans, and like it was all very new and very strange. And so this talk in 2024 was sort of an attempt to just sort of demystify some of that. And while a lot's changed in 2 and a bit years, and I hope that this session can give you a bit of a flavor of what agents can do, and when they're used in anger, what benefits that actually brings in the real world. So if you're as old as I am, this picture might rekindle some fond memories. This is SETI at home. This was a screensaver that you could run on your computer that essentially was one of the first, if not the first, distributed computing systems where your computer was sent packets to decrypt and figure out whether the signals that we're receiving from the radio telescopes pointing at space received messages that looked like aliens trying to communicate with us. So this is the search for extraterrestrial intelligence. I don't know if we found any. Maybe it did find some, but we certainly were not informed. But I thought that was quite an exciting idea, and that's sort of what inspired the project which I'm about to share. So what the project was is something that my AI friends decided to call unsorry. Are there any clever mathematics people here? People who are really good at maths? Because I'm not one of them, and if you are, I would really like to speak to you, because I really need to understand what is being created here, and you'll soon understand why. So unsorry is a system that was created by agents over the course of a couple of days, and then some, which, a little bit like SETI at home, it enables a swarm of agents which belong to me, belong to you, can belong to anybody who decides to participate. And what it does is solves mathematical theorems. So it does mathematical proofs in a language called Lean, which is used in mathematical academic circles. And I'll talk to you a little bit about that. Now, just to reiterate, this is stuff I've been working on in my spare time. I have a bit of a side gig running a community called Agentics NZ. That's the little logo there, and that's where you can find the project on GitHub if you'd like to learn a little bit more. So, how did this start? So, essentially, the idea was born when the latest, hottest new model in town arrived, which some of you might have heard of, called Fable from Anthropic. And so I saw this and I thought, oh, that's interesting, because what Anthropic have done in a very clever marketing ploy was to say, hey, you guys can have this incredible model, and it's so good because it's so good that we weren't able to release it, and it's cracking all the codes on the internet, and it's a security risk. But we'll give you something called Fable, which does all the good stuff and none of the bad stuff. But we're only going to give it to you for about 10 days or so, and then you need to pay for it. So I thought, well, here's an opportunity to do something worthwhile. So what could we do? So my plan was, well, let's just ask the AI what it thinks would be the best thing to pursue, rather than me telling it what to do. So I gave it these 6 criteria, and then I asked it to rank a range of options that we might pursue against those criteria. So just real quick, I was looking for something that could benefit humanity, looking for something that really could benefit from the best intelligence available, something that could be broken down into small chunks and then split out to a group to pull things off a backlog and to work asynchronously. Something that can be verified in software. So essentially, I can stand back and just let the system decide if the work that's been done is actually good work or not. That the work that any one participant does, or rather, their agents do, it compounds upon each other. So, if I do something, I do some work, put it into the pool, then the next person comes along, it all compounds and stacks. And lastly, and most importantly, this idea of minimum viable infrastructure, where the system has to operate with the absolute bare minimum of components to operate. Okay, so I won't go into these too much. It's been up there on the screen for a while. You had a look at some of the options that it came up with, and the number one option that was decided was formal mathematics. So something that a system that can help to prove and to verify these things. And as I understand, this is a quite a well-researched and active active in the research community. People are looking to do machine verification of these theoretical proofs that humans have come up with, and that is a beneficial body of work to contribute towards. So I'm going to give you the highlights. I have given this talk before that goes into the sort of more of the story that unfolded, which was quite a wild ride. I'm just going to give you the highlights of that today. But essentially, day one, Fable is released. Yeehaw! This is an amazing system, but as I've said, we've had to look carefully at the cybersecurity concerns with this, and therefore there are safeguards there. And on the same day, some clever guy, Pliny the Liberator, as he likes to call himself, jailbroke the system and then managed to get it to do exactly the things that it was not supposed to do, which led to some interesting outcomes, which we'll talk about. So essentially, sorry, just to step one step backwards. So the project brief and the selection criteria, this was the research stage, right? We're at stage one where we've asked the AI to go off and do all this research, okay? And then it's come back with a recommendation. Now, stage two, this was the plan, right? So I said, okay, well, that's what we're going to do. That's our outcome that we're looking for. Go off and plan the work, and give me the step by step for what's going to be built and how it's going to be built. Okay, and so that's sort of, this is where I'm starting to bring in this building out in the open approach, which I like to do. So stage three, we are in the build and test phase. So this is going from the bare bones version 0.1. We've kind of set up the structure and the architecture decision records are required to build the system. And then what we've done is we've said, okay, there's your plan, go build, and keep building until you've shipped version 1, and don't stop until it's done. And that resulted in a 7-hour stretch from 0 to 1, and unfortunately after 7 hours it got rate limited, which means you have used your allocation of tokens. Please wait for a couple of hours. So after that happened, I pushed go, and then it continued on for another hour and 45 minutes, and then we had version 1. The system worked, and I was able to use the system to generate and verify 4 proofs. So we were sort of thinking there's something here, and the group started to become interested. So what had it built? So it had built a swarm of AI agents working together to prove theorems, and so sort of super high level. What we have is a bunch of goals, open theorems that can be claimed, and then anybody with their Claude account, or with Gemini, ChatGPT, or even the local models running on their computers, if they're powerful enough, can pull down one of those theorems, and it will come up with a proof using those LLMs or deterministic systems even can contribute. And then what happens is, once it's done that, it will send it back to the system, and then the nice thing about Lean is that as a kind of a, how do I put this, as an algorithm, I suppose, it is able to check deterministically whether or not the mathematical theorem that you've provided is correct or not. right? So that is a 0 or a 1 binary process. And one of the cool things about unsorry is that if the agent isn't able to solve the problem, it actually breaks it down into smaller chunks, and then sends those chunks back into the into the start of the process, and then those chunks can then be pulled down and then claimed and worked through. So over time, we are growing this sort of library or body of machine verified mathematics, which I'm hopeful that at some point in the future we can find an actual mathematician to get these submitted into the official mathlib library where these things live in the internet. And why this is important? Well, the maths community and scientific community can then use these verified proofs in their work to sort of further the field and applications that require it. So skip a few days ahead. So we did the release. So stage 4 happened on day 3, but this was the time where things really started to take off. So at this stage we had 5 active contributors to this project, and we'd managed to generate 63 proofs from end to end. This was also the day after Fable was taken away from everybody because it was a national security risk to the US. So the US government clamped down, but thankfully the system had already been built, and so Fable had done its job, and we were able to kind of carry on with still very effective but somewhat less clever Opus models. It was fun. It was fun for me to be able to work with ex-MSD employees on this, such as Jay, who some of you might remember. He's based in Auckland, and also Adam Holt, who joined in. He's the Claude ambassador for New Zealand, based in Auckland, and other people joining in. So this is kind of a lot of fun outside of work hours, and my supportive family letting me do my weird stuff. Again, sort of jumping towards the end of the story now, because there's other things I'd like to talk about. By day 9, we had people across 4 time zones actively contributing to this project, and it's really getting quite wild. We're sort of fixing and improving the system as it's being built, and due to the asynchronous nature of the system, whereby I can pull something down, I can work on it, and then I put it back, and there's a queue, and then the processing and the verification happens in a sequential sort of factory line process. Even when if anyone knows what a pull request is, even when we've got 446 pull requests in the system, which is essentially, people are making changes at an astronomical pace, or rather their agents are, and how many problems are being solved. We had to be very agile and adaptive in solving the problems in the pipeline as they occurred, and it was a really interesting engineering challenge. So what had we achieved? By the end of 10 days, we'd proven that we were able to deploy a pretty sophisticated mathematical proof swarm using just users with their agents pointing at the system, Git, which is a version control system for code and keeping code together, and GitHub Actions, which is something that does that sort of manages the whole pipeline for us, and doing the verification of all those proofs, which is part of GitHub. So this was a sort of a community-driven platform. Our little SETI at home, which we had built, gamification into. So, if you come back, do we have the leaderboard here somewhere? No, I don't have the leaderboard. There's a leaderboard. So, and when we put the leaderboard in, people, really, the competitive spirit really kicked in, and that was fun to watch. And I guess the exciting thing is that what we have now is a body of work which hopefully might be of some benefit going forward once we do manage to get some sponsorship through the universities, which we're actively working on. So I suppose I'll just take a little pause there and take any questions before I sort of move into the next part of the talk, if anyone has any questions.
Oh yeah, Chris, I've got a quick one. Rogan here, if I might.
Yes, Rogan.
Like there's these long-standing hypothetical theorems that just near uncrackable, and they sort of get, I think there's I don't know if there's an overt rating of them, but like has in terms of some of the theorems that have been proved here, sort of are they long-standing gnarliness ones that?
Yeah. So just to clarify, so what we're not doing is solving problems that have not been solved by a human. What we're doing is doing machine verification of those problems.
Okay, get you. Nice. Sorry, I missed the first 15 minutes, but just super curious seeing the whole flow there about how. Okay, yeah.
Yeah, and so one of the interesting learnings here is, like, despite the checks we had in place to ensure that the problems that, or rather even the goals that are being, because the swarm creates the goals as well.
Yeah.
That the goals that are being put into the system are actually novel and non-trivial. People worked out ways of creating essentially farming goals that are just a little bit different, and are trivial. But we've, as I say, that's one of the improvements we've made over time, is to try and make things that are non-trivial. Yes, Georgina.
Nice.
I'm glad you clarified that because I did also think you were working on some of the unsolved theorems, because some of them actually do have really big dollar value price tags attached to solving them. So if you could get it to work for some of the ones that have prices, then you do have a foundation. So are you attempting to find novel proofs for existing solved theorems, or just validate the existing proof for the solved theorem?
The former. So it is, you get the question. So the goal is the question. A human has they've done their own verification of the theorem, and what this is doing is, with no knowledge of their proof, this is coming up with its own proof to validate their, what the human came up with.
Okay, which may or may not be the same proof for the same theorem, right?
May or may not be the same proof, but it gets the same result.
Okay, and as then, so University of Wellington, they have a math department. Are you attempting to get the proofs done by the agents?
Yes.
I don't know, formally submitted into a paper to go, okay, cool.
Yeah, so how it works is that mathlib, they have a process whereby it's essentially another, from what I can gather, another Git repository where in order to make a submission to the official mathlib library, you have to have a human being make a submission of this machine verified proof on behalf of the agent and be able to explain what this is doing and how it works, and to essentially, sponsor that through the official line. So
kind of like a peer review of a paper before the paper is submitted.
Yep.
Okay.
So that's what we're working on. We have a couple of lines, and we haven't found anyone yet, but I'm working on it. Right. Any other questions before we move on? So just to talk a little bit about my approach to learning, sort of through this worked example. Some commentary there. We have this memory limitation, and there's so much coming into the system. The pipeline's getting slow. It's a work in progress. It's a race against time. And here's our leaderboard. We have this competition, and people are really getting excited, and it's just generated this enthusiasm about this. So this is really the benefit of trying things out. Being ambitious, building out in the open. I think is the one I forgot to add to the list, but just having a go and also learning as a group. And I think that's a key one, especially with a domain that is still evolving at a rapid rate. And this is not stuff that you can learn at university. You can go to university and learn how neural networks work. You can go to uni and learn some great coding techniques and learn Java. But you're not going to learn cutting edge agentic engineering techniques unless you just do it and you try it and you find other people who are into it, and you build on each other's knowledge about what works and what doesn't work. And you have the benefit of that continuous feedback and a safe space, and just to emphasize that gamification piece. And sort of my approach to working with these agents is you've got to kind of, I think, train yourself to not tell the agent what to do. You've really got to get into a dialogue. Your job really at the outset is to describe the outcome you're looking for. And if you're not sure, just work with the agent on that problem together. Have the agent prompt you. Don't prompt it. Have it ask you questions so that you can refine your thinking. And again, don't tell it how to do the work. It will find a way, and it will probably come up with some pretty creative approaches that you might not have thought of. So don't treat the AI as an order taker. Treat it as a creative partner. And the other thing I would emphasize is really put your efforts into the input rather than the output. So you'll get a better quality, and you'll have less kind of turns of the handle if you just spend more time on getting as much good context into the model before you say go. Right. The only word of caution I would say is don't give it too much, because think of the context as sort of a short-term memory. It will reach a point where you're, the less context, you're sort of in the smart zone. But once you cross the threshold of too much in the context, it starts to get into the dumb zone. So you want to just try to find the sweet spot for how much you are feeding it. So a question for you. That's a woodchuck in the top corner there. If you didn't know, I didn't know they look like that. They look a bit like a beaver. How much code could an architect code, and if an architect could code? And the answer is actually quite a substantial amount. So what you're looking at there is just the breakdown of the amount of lines of code in a couple of projects. So the first project being the unsorry project. Once you take out all the blanks and the comments and things, and by the way, you'll see a lot of markdown there. You're getting up to like 210,000 lines of code for a project developed across the span of about 10 days. And interestingly enough, Markdown, if you didn't know, is just a simple way of formatting text. So this project has a load of documentation in it. And I guess, code is just another form of documentation. Another project I'll show you is called Iris. This one I've been spending a bit more time on, and that one so far is up to about 350,000 lines. And just a wild sort of throwaway stat. This is my, and I don't mean to brag here. It's an interesting data point around work over time. So this is my GitHub contributions to all of the repositories I've got on GitHub in the last year. That's 11,000 contributions. So there's each of those as a commit. So I've put some code in there. And it looks quite, it looks like I haven't been doing much around there. And there is this big gap where honestly, that was a burnout for me. I kind of hit a wall in August last year, and I had a few months off. But what this is illustrating is actually that during the week and a bit of unsorry, my agents were so busy verifying all of the proofs that everyone had submitted. In a single day, it did 1,100 commits. So it's the stats are just, I don't know, if you know about this stuff, it's pretty ridiculous. So conveniently, there is this well-known design approach called the double diamond, which Mark Tan, if he's on the line, has talked about in the past, which is an approach to design where you start with a problem and then you go off and you do a discovery, and so you're kind of exploring and you're opening up, and then once you've got all your information, you're constraining again. You're zooming in on a definition, and that's the problem statement. This is how we're going to address it, and then now we're going to go and sort of develop this idea, and then again we're going to tighten it down and get it packaged up, and then put it out into the world. And so this is quite convenient, as this sort of quite well described my approach to this coding challenge with agents, where first and foremost I'll go off and do a bunch of research, and I'll go off and get loads of information, and then we start to zero in on a plan, and now we've sort of got our plan and our approach honed in, and then we go out and do our build and our test, which is actually really actually tightly coupled as the same process. And then once we've built, we then sort of package things up and tighten the screws and put out a release. So I sort of follow this as a two-phase approach, where I do that sort of first cut out into a UAT environment, and then I'll gather a load of feedback based on the UAT, and then that forms the phase two, which is across the bottom, where I'll do my review, my plan, and then sort of the fixed tests approach, and then release to prod. So that's how I use the double diamond for this use case. So architecture. What does this mean for architecture? Are we still in the business of drinking coffee? Certainly. Are we still in the business of whiteboarding things? Absolutely. But I think if we bring in some of this thinking around automating a lot of these processes that are related to architecture, I think that we can start to sort of rethink how we get that work done, and how we might accelerate lot of these activities that we would usually associate with architecture and maybe other domains. This may also apply to. So I'd really like to start that off with a discussion around architecture decision records, or ADRs. This is a well-known approach in architecture and software engineering. It's something that we brought into MSD way back in 2022, and it's what an ADR is just a simplified way of describing a change or a decision, which is sort of the syntax that we chose was called the Y syntax, where, in the context of a given change, facing, what are the concerns or what is the problem statement, we decided to go with, a given option or approach. And while we considered a bunch of other approaches and neglected to choose those ones in order to achieve certain benefits, accepting that there might be some, opportunity cost lost in doing that. So this approach has really been the cornerstone of how I go about building, which it works for me because I'm an architect and I don't code. I don't understand coding, but it turns out that if I bring my domain knowledge in architecture, this is my comfort zone, and I'm able to actually get some pretty good outcomes using my architectural approaches to coding with agents. So this is something that I apply to every single project I'm working on, and it scales really, really well. And it really just gives the kind of, it's the steering wheel I have to ensure that the build stays on track and is really honed in what I've asked for. They form, what some, if you might know, sort of these invariants in a project where, we can't really go outside of what has been locked in. And the other nice thing it does is it's tracking dependencies between all these ADRs, and then below all these ADRs, we have the specifications, okay? So the ADRs are, one part of the protocols which I apply to every single plan I carry out when doing development projects using agents. And as I mentioned, specifications are the second one. So, your specifications really, that's your design. Okay. So, like in MSD, we come to the technical architecture committee, and whenever there's a architecturally significant change, we get approval or endorsement to do that change, and then we go off and we create our designs based on those core architectural decisions. So really, we're doing the same thing here, and we're just doing it at scale. And just sort of to zoom through some of the other ones, we're doing test-driven development. We are creating for every new bit of functionality we create, we're creating a branch. We've got a change log so that we can see, every single change we're making. There's an audit trail. We're doing releases, which just sort of gives it a numbered release. Another thing we're doing is this is sort of just to introduce you to the idea of an MCP. Now that is just a way of bringing context into a model from another system, and in this case it's context 7, and so what's happening there is we're not just relying on the knowledge of, let's say, Python or Java or whatever the coding language is. We're not just relying on what's been baked in to the model. we are actually saying, okay, well, if you're going to use Java, actually go off and look up the specification for Java on best practice and how it works and syntax and everything, and then just bring that in to the model. So it gives a better quality and better output. We're not going to mock anything up. We're not doing stubs or placeholders. All we're doing is creating production-ready code here. We're going to pull down, if we're using other software, sometimes when we're building software, we're bringing in dependencies. So we want to make sure that we're bringing in the latest dependencies. Our documentation is always maintained and accurate. And another thing here is don't repeat yourself. So this one is a kind of a standard software development practice where we're not going to build the same thing twice. If we need to build a thing, we're going to check if something like that, if that function already exists, we can just use that and reuse that or adapt it. So that's the agent development protocols. Now I'm about to step into the demo here for sort of how do we bring in some of the thinking around automating architecture. So I'll just zoom through this. So this is where we are using Claude in this case, plus an architectural modeling tool that I've built called Iris. And how do we then build, for argument's sake, we haven't done all the architecture models yet, but we can sort of infer all these things and develop all the models based on all the code that's been produced. So in this case, we've produced in a system called unsorry. What we're going to do is jump into Claude, and we're going to say to Claude, hey, Claude, can you use Iris, which is our modeling system, and the MCP server I've built into Iris, to tell me what kind of models can you create? Like, can you do UML? Can you do C4? Can you do capability diagrams? Can you do business process diagrams? And it comes back, and then I'll say, okay, can you go and look at the unsorry code and then figure out how it all works, and then come and recommend a range of diagrams or models that can represent this. So this is the architectural modeling. And then, okay, once you've given me the plan of all the diagrams you're going to create, just go in and deploy it in Iris. And that's what happened. So that's what I'm about to show you. Here we go. Oops, I stopped sharing. I need to close the presentation, re-share the screen. There we go. Okay. Hopefully you guys can see the dashboard. So we're on Iris. Iris is I'm running out of time. Iris is really sort of, I would call it a knowledge-centric or repository-centric modeling tool. It's actually less about the drawing of the model and more about all of the rich data that the model represents. So each of these, this is a knowledge graph, right? Each of these things is a collection of information. So, for example, let's just go into the unsorry collection here. So within the unsorry collection, we can see there are five sets of packages, I guess we could say. And within the first set, we've just asked, or rather, we've agreed to some sort of textual documentation here. So we'll click on, this is the overview, right? So of all of the various groups of information that have been put into Iris. we've got sort of at a glance, we've got the whole system context and how it all fits together. We've got the sequence diagrams, we've got the capability map and all that stuff. Now, I haven't drawn this, just to be clear. Claude has drawn this using the MCP server I've given it to Iris and all the context that's been brought in from the unsorry repository. So just to sort of glance through at some of this stuff. So it's written this unsorry at a glance, what it is, the design decisions, how the loop works, phases of the project. I'm going to zoom through this, right? So design principles, blah, 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 all that stuff. All of the ADRs that have been created and sort of grouped. It's come up with this idea of a spine. So it's sort of grouped all those ADRs into thematic clusters, which is actually kind of useful to understand what the heck has been built. I'm just going to jump back into the sets, show you some more examples. So this one, this is the system context. This one turned out really well. So I'll just bring that up a bit larger. So what have we got? We've got down the left. This is a C4 diagram. So we're getting we're getting the actors. So we've got the operator or the founder. That's me. We've got contributors with right access. We've got fork contributors, which is another thing, and then upstream sponsors. That would be the mathematical genius who's going to help us out here. And then we've got all of the various components. We've got the LLM providers, we've got mathlib library, we've got the benchmarks that we've built in, we've got the front end, which shows us the leaderboard and all that stuff. And look, it's just put all this information in here for us, which is rather convenient. And we can see that this element, this node in the diagram is an element in Iris, right? So you can see that if you have good eyes, you can see a little 1 in the top corner there. But what's cool here is that we have a many-to-one, or rather a one-to-many relationship where, this LLM providers thing can apply to many other diagrams, right? So we can start to build like a really nice picture of our enterprise. I won't bore you with all of these. I'm just going to zoom through and just sort of give you a flavor, and then I'll leave some time for questions. But there was one really neat one that I thought I would show you, or a couple. This is where the BPMN, yeah. So it actually does BPMN as well. So I've built in the BPMN business process notation into this, and it's quite good at building business process diagrams. And yeah, that's it. So that's pretty much the talk. Unsorry is here. You can come and check it out. The swarm gives you a bit of this is sort of the entry point into the system, where if you come to the swarm, you can see the leaderboard where things have sort of died off, and I've been fixing the pipeline, but this is sort of over time, everything. We've got now 4,749 proofs. We have the leaderboard. The only reason I'm at the top is because I'm verifying everyone's proofs, and that's worth something. We have all these goals that you can come in and claim. And yeah, the other neat thing is that someone in our guy in Hong Kong, not Hong Kong, in New York built, this is all of the proofs in a graph, right? And what he's done is he's figured out a way of highlighting all of those farmed proofs. We can see this cluster, and these are restatements, so that we know they're no good, right? So it's a cool way of visualizing it. So anyway, I've left you 5 minutes or more if you want to go over to have any other questions. Put your hand up if you would like to say something. Is that a hand? Okay, go JP.
Yeah, so I want to go into the depths with you on how to. So if I have a couple of problems that I want to apply to that same thing,
Yep.
I'd like to maybe get a bit more of a 101 driving lesson on some of this stuff. While I think I'm quite familiar with a lot of this, especially using AIs to leverage this, I gotta say, you're definitely on a whole nother level, and I'm very impressed as a former developer.
The interesting thing about this system is that I think that arguably the value of the system is not the solving of mathematical proofs. The value is that we've actually demonstrated a generalized system where you can get research done in a swarm, right? And we've built it in such a way that it can be generalized into other domains, which is very exciting, and that's where I'll be taking it next. Anybody else? Georgina.
I'm just wondering, so Johannes, are you going to just riff off that and get it pointed at our Git repositories so that our current state analysis becomes real? Is that kind of the plan?
Yeah, that might be a topic offline. I'm doing a few things to try and figure out some ways to get non-deterministic analysis on just a broad picture of where to aim. So we figure out where's the biggest problem where we point at, but then figuring out how we can use this to create a deterministic regeneration back to
verifiable current state without
exactly.
the humans going to find it themselves.
Exactly.
And the dependency graphs and the business specs.
Yep, one step at a time. At the moment, I'm just purely looking at code quality, but I think that's optimizing for 10 years ago. I think the specs and outcomes is actually what we should be aiming for.
I think it's different areas have different hot topics, right? And so if you happen to be in an area which is looking at code vulnerabilities, then absolutely what you want better scanning of the code because that is your topic area. If what you're trying to do is unpick current state so you can figure out what to do and what to do next, then really you're looking for the business specs, right? It's just a different purpose, but it's the same path.
Yep.
Grant.
Yes, so the US government cut off Fable and Mythos. So they effectively cut you off at your feet for this project, have they? Or if you're managing to carry on, but
at day 4 they cut it off, but by day 3 we had built the system. So the system was built by Fable, and then we were able to continue it and improve it after that, just using some slightly weaker models. But by the way, Fable's back. Yeehaw. Until July the 7th, which is my birthday. Thanks for nothing.
Got 4 more days.
You can have it after July 7th. You just got to pay more.
Yeah.
Hi, Chris. Thank you so much for this wonderful session. So I've got no questions, but because obviously I'm not a super IT person, but I really wanted to say thank you for having us in the meeting, and I really enjoyed going through this whole techie stuff with you. So super interesting, and I have jotted some terms which I might just dive in a bit deep, and it would be aiming to know more. Thank you so much once
great.
again.
Thank you. I really appreciate that. Georgina.
Yeah, I noticed you specifically mentioned Claude or Anthropic, a few times in there. Have you ever explored other models? I know Anthropic's at the top of the game at the moment, but have you explored any of the other frontier models?
I am AI curious. I do like to dabble. I did make the switch for personal reasons to Anthropic, which I felt was a more ethical choice. But it turns out that they're all much of a muchness in terms of on the ethical spectrum. And I know that what can we do now at MSD? We've got everybody has access to Copilot chat. You can use GPT 5.5 thinking in there and actually do some pretty incredible stuff. And you can use it as much as you like. So I'd encourage you to use that. I use Claude as my daily driver. I also use local models. I've got some hardware at home, and I dabble around with those. And they're not as strong as the frontier stuff, but they're good for certain tasks.
Yep, we could probably continue that conversation offline.
Yep.
Particularly interested in how the Mythos class models are going to come out, and probably not just from the US.
100%. Okay, we're at time. Happy to take more questions if you like, or we can wrap it up. Okay. All right. Well, thanks everyone. You know where to find me if you would like to learn more. I'm always happy to provide advice and guidance. Cheers, everyone.
Thank you. It was awesome.
Thank you.
Chris.
Thanks, Chris.
Thank you. Bye.
Awesome. Thanks, Chris.
Thank you.